Hi everyone, so this is a video about 2.1 on functions. So chapter 2 pretty much will give you all your basic knowledge for functions and different types of functions. So it's pretty lengthy. There's around 6 sections, maybe 7 in this chapter. So first we'll start with, if we recall that from previous sections, remember we could have equations in this format. And this, remember, or when you graph these sort of equations, solve for y, you get lines. Okay. So equations in 2 variables, that is a little bit more complicated. So in the first one, that is an equation in 2 variables. The x and the y are your variables. But let's say you change the x to have a different power and the y also. You might arrive at something like this or that. And they're very difficult to graph. So one approach to graph these is you get a solution set. So remember what this is. These are values of x and y that when you plug them in, they satisfy. Okay. So we'll do an example here. So you plot enough of the points in the solution set to get your graphs. And for some of the questions on your homework, you'll have this, and you'll, if it's an x squared, like this one, to plot this in MATLAB, you want to use the quadratic tool. So that looks like a U when you open up the graphing. The other ones will have a cubic, and that looks kind of like this. So this is for, if your highest power is x to the third. You should only see x squared and x to the third. If you see x, that's, a line, which is just x. Okay? So it looks something like this. Okay? So if I want to do 9 minus x squared. So typically in MATLAB, it will ask you to do some few points. So we're going to look at -2, -1, 0, 1, and 2. Pretty much you just plug them in. So you could use Desmos. You could look at Desmos with your graph, which I would suggest doing that to kind of give some emphasis on how you make this table. Because remember, you can use Desmos for anything. So if we go over here to Desmos, okay, so I'm going to go to Safari, use Desmos, okay. So we see that if I type in that equation, y equals 9 minus x, and then don't forget your squared, okay. We see it looks like this. Right? So you can move it around with your pencil as well, your cursor. So one thing to note here, when you type in an equation, Desmos will not let you automatically fit it to see the equation. Sometimes you might have to zoom out. If you're on an iPad, use your fingers, or you might have to use your mouse. If you have a scroller, you can scroll out. Or on the side here under the wrench on the right, you can zoom out this way to click the minus and zoom in with the plus. Okay. So we see we have this here, that this is a quadratic, okay. Also because x is squared, okay. So how would we actually get some of these points? So how would I figure out what's the y value if x is -2? So I just have to plug it in. So 9 minus -2 squared will give me 9 minus 4, right? And then this will give me a 5. So 2, 5. Okay. And one thing to note here is this sort of diagram will be, it's not going to contain everything, okay? So, and you'll see what I mean. If I plug in, so let's plot to -5, or -2, 5. And now, let's plug in -1. So this is -1 squared is 1, so 9 minus 1 would give me an 8. So at 1 we're at 8, but it's not on my graph here, so I'm going to say it's going to be maybe like right here. Okay. And then at 0, 9 minus 0 squared would be 9 minus 0, and that will be a 9 if I subtract those. So at 0 I get 9, so a little bit higher here. And then if I plug in my 1, I get 9 minus 1 because 1 squared is 1. And this will give me an 8. Okay. And then likewise a 2. 9 minus 2 squared will give me a 4, which will give me a 5. Okay, so you see there is some sort of symmetry going on here that we can see. If we plot everything together, we know it looks like this. Okay, so it looks like a quadratic. So this is plotting by, you do as many points as you want here, but we're only going to do 5. Usually -2 to 2 works. Now for some things you might not see the whole picture. So like for instance, you could do this one here. Okay. So now what I want to do is, instead of working this one out, let's type this in Desmos and see what it looks like. Okay. So we're going to go over to Desmos here. Because you want to think you can use Desmos whatever you like. So I'm going to do another one. We had that it's y equals minus x, and then the power key here to the third. So that AB key. Okay. And then we're going to hit right to drop down. And then plus 2. Well, not times. Oops. Plus. And then a 2. Okay. So I'm going to hide this one above me. So I see this is what I have here. So if you were going to plot this in MATLAB, you need at least some points, right? So this is a cubic, so you need some points. So we have, I wouldn't do that point. Okay. So you have one at 0, 2. You could say we have, right? What would be some other points? Okay. So you could think about, where is it at 1? So we can use here, maybe I can annotate, but one thing I will say is, let me see. So if I want to annotate here, I can see, give me just 1 second. Okay. So count over here. So you see I can, along this curve, where would it be? And you can see my cursor here. So it looks like, at -2, it's near, at 2, it's near -5. That would be a point. And then at 1, it's at 1. At 0, it's at 2. At -1, it looks to be near 3. Okay. And then at -2, it's at 10. So all these are points that you could use, and you think these are easily to read. Okay. You can always check, right? Let's say I'm not really sure if -2 is 10. So remember, just plug in -2 for your x. So negative parentheses, -2, close parentheses, raised to the third power. And then I'm going to add 2. And I get 10. So I know that -2, 10 would be an ordered pair. Okay. So do try to utilize Desmos to help you with all of the graphing. It is very, very useful. Okay. So use Desmos. Right. So you can look at this match problem here. You can look at the graph. You can do it on Desmos, see what they get. And there's also, so I would not do this one. Do not do this one. This is a horrible problem. Okay. We're never going to have anything that looks that crazy. Okay. So now we're going to talk about correspondence. So just want to say that some of the problems at the beginning of the MyLab will have graphing point by point. So if you do need any assistance, shoot me an email. Okay. So for this correspondence here, a function is a correspondence between two sets of elements such that each element in the first set, there corresponds one and only one element in the second set. So the first set is called the domain, and the second set is called the range. Okay. So what are the key concept of function. So the functions is just a special rule where it tells you if you have these things in your domain, where are they going to go in your range? Okay. So let's identify functions here. Okay. So you'll see here, one thing to note, right here, just to make sure that there are two sets of elements in the first, such that element, and each element in the first set there corresponds one and only one element in the second. Okay, so for everything in the domain, it can only go to one thing in the range. Okay, it can't go to two things. So if we look at table 1, this is a great example because every piece of the domain is sent somewhere in the range. Now, if I wanted to modify this, what I could do would be, let's say number -2, right? Let's say it can also go to 1. If I make this slight change and say that -2 goes to -8 and goes to +1, that would not be a function. Okay. So remember, each element in the first set, which is the domain, there corresponds one and only one element in the second set. So it can't go to two things in the range. Okay. So you want to think we're going to delete this because that's just to show you what would not make a function. So this right now is a function. Okay. Every element in domain only goes to one element in the range. Okay. No, not range. Okay. So let's look at this one. We see this is also good. This is great. So some people might confuse this with, hey, wait, what about 4 and 1 here? Two things are going to that. That's fine because that's in the range. We don't want to see two arrows coming out of the same domain. It doesn't matter if they're all going to the same range value. Perfectly fine. So you see here, this is where the problem comes in. 9 can go to 3 or -3. Well, which one is it? So in mathematics, you can think of a function as a machine or a process. If I plug in a value, I need to get a value out. And it has to be consistent or the same. That's like saying, oh, if I do my taxes, I might not owe anything. But the same person that has the same income might owe $100. That's not fair, right? So a function is trying to keep everything fair and consistent. So these, not good. This is not a function. Because the domain pieces are repeating. Okay, so 1 is being sent to -1 and 1 is being sent to -1. 4 is being sent to 2 and 4 is being sent to -2. So that's why they're not a function. Not an example of a function. So most functions in this course have domains and ranges. So the graph of such function is the set of all points, where x is the element of the domain and y is the range. The correspondence between the domain and range elements is often specified by an equation in two variables with the property that each domain value is associated with one and only range value represents a. Okay, so remember, what are we talking about, right? So let's make sure we get the right vocab here. So take a moment. What do you think it would be? Just remember, so an equation So it will specify a function, okay? So hopefully you can see that. This is another way to think about it. So equation in two variables with a property that each domain is associated with only one and only one in the range, okay? So this last part here, an equation in two variables with the property that there is at least one domain value that's associated with more than one range. So this does not represent a function, okay? That means if I plug in two different x values, if I plug in the same x value, two different y values will make it work. Okay. So consider the equation y equals x times x minus 1. Okay. So this is fine that I can represent this as a function. Okay. There's no issue here. Okay. And if you think about it, for whatever I plug in, y is only going to be equal to one value. Y can't be two different values, okay? And one reason for that is this says y equals x times x minus 1. Now, how would I modify this to not be a function in case you're curious? Well, there have to be two values for y, right? So one possibility is if I wrote it like this, if I modified it, this is not a function. That's because, let's say for instance, I plug in 2 for x. If x is 2, then y squared equals 2 times 2 minus 1. So y squared would equal 2. So that means what would y have to be? So I would do the square root. So y would equal plus or minus the square root of 2. So there's two possible values I can plug in. Because remember, when you square something, a negative number or a positive number, when you square it, will give you the same number. So typically, if y is raised to a nice odd power, it's a function. Okay? If it's an even power, it would not be. Okay. So why is it a function? Every element in domain only has one element in range. Or you could say it's because your y variable is raised to the first power. That would work. So you'll see here. So if an equation in two variables, we only get exactly one output. The value for the dependent variable for each input, then the equation specifies a function. Okay. The graph of such function and the graph of such a function is the graph of the equation. Okay. So if there's more than one output for a given input, this is not. So that means if I have more than one y value for every x value, then it would not be a function. So we see here that this would specify. So you could possibly think if every, right? So usually what you do is you want to solve for y, right? Or you could do that shortcut I taught you, that if y is raised to the first power, so look at y. So this is y to the first, okay? So this is fine. So it's a function. So for instance, how could you check if I just take some random number, y equals 3, let me say I'm going to plug in 2 for x. And I get that 4y minus 6 equals 8. So if I add it over, I get 4y equals plus 6 plus 6, 14. So y equals 14 over 4 or 7 over 2. Okay, so what you could do then is, okay, I only got one y value there, not 2. Okay. You could plug a different value in, like 0. 4y minus 3 times 0 equals 8. So 4y equals 8. Y would be 2 because I divide by 4 here. I divide by 4 here from before. Show you that step. Only one value, so this seems fine to be a function. I only get one y. But if I look at this next one here, let's say if I plug in 0, y squared equals 0, sorry, not equals, minus 0 squared equals 9. So y squared equals 9. So if I take a square root now, so that would be y squared equals plus or minus square root 9, which means that y would equal plus or minus 3. And something that you could do is, since we have Desmos, it's easier to somehow graph these and then use a different technique. And we'll talk about that. So this, since we have two y values here, this is not a function. So for that one x value I plugged in, I get two y values, not a function. So this is for figure A. So look at the graph. It looks nice. You'll see a vertical line here. We'll get that in a second. And this is the second one. See a vertical line here. What happens? Crosses at 2 points. Okay. So there's a reason for this. So this is called the vertical line test, okay, which we mentioned soon. We'll talk about that. So that's why I'm going to mention graphing it on Desmos, seeing what you get. So you can look at this match problem here. So what does the vertical line test say? If any vertical line passes through 2 or more points on your function, it's not a function. Okay, if not passes through 2 or more points on your graph, then it's not a function. Okay. So if we go up here, if I draw as many vertical lines as I can, all of them only hit my original point, my original graph once. So this passes the vertical line test. Meaning it's a function. Okay. This one, if I draw even another one, it hits twice, hits twice, hits twice. So if anywhere it hits twice, not a function. So this fails the vertical line test. So not a function. So just think that if y can't repeat, if you draw a vertical line, sorry, not y can't repeat. You can't have the 2 or more y values for the same x. So when you draw a vertical line, it's kind of asking that, because remember, vertical line means x is the same value. Okay. So if we look down here, we see here, if I look at this function, would it pass? Would it fail? If I draw any vertical line here, it hits twice. So it fails the vertical line test. So not a function. And for this next one, this actually passes. If I draw as many vertical lines as I want, it's never going to hit twice. So this is okay. It's a function. Passes the test. Okay. So regarding domains of functions, now we're going to shift gears a little bit and talk about domains. Okay. So remember, for this, if a function is specified by an equation and the domain is not indicated, then we assume the domain is a set of all real numbers. Okay. You can remember the independent variable are the inputs, and the dependent variable are the outputs. Remember, independent variable is usually your x's, dependent is typically your y's. And the range is the set of all the outputs. So what would be the domain of this sort of function? So remember, you can't take the square root of a negative number. So I want to take what's inside, which is 4 minus x, and say it has to be greater than or equal to 0. And that'll give me all the possible inputs I can have. So if I solve this for x, I'm going to subtract my 4 first. So I get negative x is greater than or equal to minus 4. And then I need x to be by itself. So I'm going to divide by the coefficient, which is negative 1. And remember, when I divide by negative 1, you change direction of your inequality. So x would be less than or equal to 4. So this is your domain. Or you could write it as interval notation, as we've learned from previous sections. Okay. You could practice with match problem 3 here. So function notation. So function notation gives an alternate method for naming functions. And we've seen this before. I mentioned it in some previous videos. You might have seen this from middle school, high school. Instead of saying y equals, if I have y equals this, y equals this, if I have a lot of equations for y equals, I could just rename them and say, well, this first one I'm going to use f, the second one I'm going to use g. So instead of writing y equals, I just say f of x equals what's on the right side. And likewise, instead of g, it represents this, g of x will represent that. So the g of x replaces your y. Likewise with the f of x replaces the y. So the f of x is used in place of y to designate that the number and the range of f to which y is paired to, right? So it's just one way of talking about it. So for instance, we have f of x is this, g of x is this, and h of x is this. And I want to evaluate what is f of 6. So I don't plug it in all three, I only plug it in f. What would be the output if I plugged in 6 for x? Okay. So let's plug in 6. So f of 6 would equal 12 over 6 minus 2. And then I'm just going to simplify this. This is 12 over 4. So I get 3. So what I'm going to say is this means that f of 6 equals 3. So what I could get from this is that the ordered pair is 6, 3 also. So make sure you understand if you have a function value, so f of 6 is 3, this also means that if you were to graph this, I would go through the point 6, 3, because 6 is your x, 3 is your y. Okay. The next one, if I do g of negative 2. So g of negative 2 would equal 1 minus negative 2 all squared. So when you plug in a negative, you want to put parentheses around wherever you plug it in. And we're just going to do order of operations to simplify. So this would be 1 minus 4, which is a minus 3. So then this tells us that g of negative 2 is a minus 3. Now, if you were going to look at the ordered pair for this, if you were just curious about it, the ordered pair would be, why did I write it that way? I'm already thinking about writing it in terms of ordered pair. This would be negative 3. So as an ordered pair, you could see this as negative 2 comma negative 3. And then we'll do h of minus 2. So h of minus 2 would be square root, plug in my minus 2, minus 1. So I need to simplify what's underneath the square root. So that would be square root of minus 3. So this doesn't exist, right? So you can't take, so that means we plugged in a value that doesn't work in our function, so it's not in the domain. So in this case, negative 2 of h of x, okay? So it's not in the domain because I can't get what this value is. I can't take the square root of negative 3. Okay. So continuing on. So if you want to practice part D, you can here, but just think it's going to be f of 0, so figure out what this is first. So I would practice a bit, see if you can get that f of 0 is -6. See if you can get g of 1 is 0. And see if you can get if h of 10 is 3. Now once you have all these, we're just going to add the first two and subtract the h. Okay, so this will be -6 plus 0 minus 3. So this will be -9. And there is no ordered pair that goes with this because we're combining a lot of functions. Okay, so you can look at match problem 4 here. If you're wanting some extra practice, do think here that this one, they find f of 3, they find h of 5, and then they divide the 2. Okay. Now for this next one here, there's some things you want to realize. If you see a fraction, I want to think you can't divide by 0. So take your denominator and say that x minus 2 cannot equal 0. So if we solve this, we get, so adding 2 to both sides. So x cannot equal 2. So this is my domain. So it's everything except 2. So as interval notation, we want everything before 2, union everything after 2. Okay. So if you want everything except for, let's say, 6, you write this instead of 2, you'd put a 6. Okay. So remember, when you have a fraction, you can't divide by 0. Now for G, you don't see anything weird here. There's no fractions, no square roots. So usually it's everything is fine. So this will usually be -infinity to infinity. Right? I can plug in any value for x for G. And then for H, it is one of the special ones. We kind of did this earlier. You can't take the square root of a negative number. So inside square root must be positive or 0. So that 1 minus x, right? That's what h is. Oh, sorry, x minus 1. Okay, so if I do x minus 1, then we have to say that's greater than or equal to 0. And then you want to solve it for x. So we add 1. So I get x is greater than or equal to 1. So this is my domain. So I want everything greater than or equal to 1. So just remember, since it's equal to 1, bracket 1, comma, infinity. Okay. So you can practice with match problem 5. So some of the harder stuff here is the difference quotient, which a lot of people freak out about, and it's understandable. So one thing to note is what the difference quotient represent is the slope at x on graph of f of x. So the difference quotient represents the rate of change at x, or if you're going to graph it and figure out what's the slope. Okay, so in this case, if x was 3, then it would represent the slope at 3. Okay. If x was -10, then it would represent the slope at -10. Okay. So we have an example here. Find the difference quotient for 2 minus x. So I'll do this to the side here. You want to think, I need to figure out what is f of x plus h. What is f of x? And then I'm going to divide by h. So you'll see here, we already have f of x. So this part will be f of x, right? Because it's the exact same. But to figure out f of x plus h, if I know this is true, then f of x plus h. For all the x's I see, I'm going to plug in x plus h. So it'd be 2 times x plus h plus 1. So if I distribute the 2, I get 2x plus 2h plus 1. So that is what f of x plus h is. I'm not adding h to the end, okay? So you want to make sure you understand that f of x plus h is not the same as, right? If h is inside those parentheses, you're going to plug it in with your x. So it's x plus h that you're plugging in. Okay, you can think of it like this. If I wanted to do f of happy face, okay, then this I plug it in for all the x's. So it'd be 2 times happy face plus 1. And that would be what f of happy face is. So now I have that. I can write my top part. So the first part will be 2x plus 2h plus 1. And then I'm going to subtract f of x, which is 2x plus 1, all divided by h. So you want to think, well, I have 2x plus 2h minus 1 minus 2x minus. So I'm minusing this part, but you'll notice I have that written here, and I have that written here. So those parts will cross out. So only thing left is 2h over h, which simplifies to 2. Okay, so this tells me that the slope for any value on my graph is 2, which I know if this is 2x plus 1, the slope is 2. Okay, so we're not going to worry about this squared here. We'll do that a little bit later, but if you want to, you can think about it, but I'm not doing the difference quotient of this. Okay, we'll practice this in this example here, because this is one you'll see in your MyLab. Okay. So one thing you want to note is that for the first part, I just want f of a. So that means instead of x, I'm going to write a for all the x's. So that would just be a squared minus 2a plus 7. And that's it. For part B, for all the x's I see, I'm not going to write a like in part A, but I'm going to write a plus h for all of them. Okay, so that means I have a plus h squared minus 2 times a plus h plus 7. And now we need to somehow simplify this. So the middle part here isn't bad, but this part, so off to the side, what is a plus h all squared? That means it's a plus h. I have to write twice. And then I need to FOIL. So some of my students in previous class, like the box method, you have a plus h. Then you have a plus h. So you just fill in the box. This will be a squared. This will be ah. This will be ah. This will be h squared. So all together, add everything up. This will be a squared plus 2ah plus h squared. So that's what this first part here is. And then I'm going to distribute that minus 2. And there we have it. Now for part C, it says it wants me to take part B and subtract part A. So a squared plus 2ah plus h squared minus 2a minus 2h plus 7 minus part A. So I'm going to minus all of this. And now that you see, well, I'm going to subtract a squared, but I already have an a squared here at the beginning, so these cross out. But then I'm also taking away a 2a, but there's a minus 2a here. And then I'm taking away a 7, but there's a 7 there. So what's left is just a 2ah plus h squared minus 2h. And then, unfortunately, in part D, it wants me to take what I got from part C, which is this top part, and divide it by h. What happens? Well, h is in everything, so it crosses out with every h on top. Do not make the mistake of only crossing out once. It crosses out with all the h's. So this one will go away. This one will reduce to 1. And this will go away. So then that h will go away. It has to go with every, you can think of it like this. It goes into every one. So cross out, make a 1 for your power there, cross out. So it'll be 2a plus h minus 2. Okay. You can practice on this match problem here if you'd like. Last but not least, we get to profit analysis. So manufacturing company has cost C, which includes fixed costs, and we've talked about this in the previous lecture. Those are costs that pretty much are plant overhead, production design, setup, and promotion. And then there's variable costs. And remember, variable costs change depending on how many items are produced. We also have talked about revenue before. Now remember, if revenue is less than cost, the company is losing money, so it takes a loss. If revenue and cost equal, it breaks even. And then if revenue is greater than cost, it makes money or it makes a profit. And remember that profit is revenue minus cost. So instead of thinking of revenue is less than cost, it's just the profit is 0. Instead of assuming they're equal, profit is 0. Instead of assuming that revenue is greater than cost, the profit is greater than 0. So one thing you want to think about is when you work on these word problems, that you understand what they're asking you. So you want to think profit is capital P. And they have a tiny p here, which is for the price demand. We've seen this before. So the price demand specifies the relationship between the demand of our product X, so that's the quantity, and the price for that product, and that would be P. So this ordered pair, XP, if X items can be sold at price P per item. Okay. So you think about if the price of an item increases, how does it impact the sales? Okay. If the price of the item decreases, how does it impact the sales? So think about these two things. So we want to think the revenue is what? The revenue, R, is equal to the number of items sold multiplied by the price per item. So it's X times P. Remember, P is this equation here, your P of X. So in this next example here, if I have P of X equals 1,000 minus 5X, where X is the number of items and P of X represents the price, determine the revenue function and find the revenue if 50 items are sold. So remember, revenue in terms of X equals X times your price demand function. So X times 1,000 minus 5X would be 1,000X minus 5X squared. Now, if we want to find the revenue at 50, we're going to plug in 50 for X here. So revenue at 50, plug in 50 for all the X's, so it would be 1,000 x 50 minus 5 and 50 squared. Or you can see it like this. You could go over to Desmos we said that revenue, so R parentheses X equals X times parentheses 1,000 minus 5X. So I'm going to get rid of these other ones here. So this is your revenue. It's hard to see this, so you could modify the window if you wanted to. Or if you wrote it like this, the next one we can just say, I want the revenue at 50. I get 37,500. Now in your MyLab, it might not like that you write your revenue like this. So we could always say, instead of this, we could write it to where it's the distributed form. 7,000x minus 5x squared. But then we could say this is just, I'm just going to say this is y equals. And you'll see what happens. The two lines have kind of, it looks really weird. So this is the thing that you need to practice with here. So if I want to plot this, we see that, to see the whole picture, it goes from 100 to 200. So click on the wrench. X is, the lowest is 100, the highest is 200 when it's above the axis. And then you just want a really large number. So you could say 10,000. And you could do one more, and now we have it. So getting the right display does take time, so practice with this problem. So we see that the two lines are technically the same, so we have successfully graphed this and didn't make a mistake typing it in. So this would be, okay, that would be your revenue, 37,500. So for this next part here, we have that cost, price, demand, and revenue functions are often represented by these function names: C of X, tiny p of X, and R of X. X represents the number of items manufactured and sold. And they have these formats, so they say that C of X is this. So remember, this is your fixed, which is your A, your variable cost, which is from your BX. So fixed, we said this would be A, and this would be your BX for your variable cost. And then your price demand, X is the number of items that can be sold at P dollars per item. And then your revenue is X times that equation. And then it brings everything together with your profit. You subtract the two, so we get this hot mess. So this can seem very confusing because there's so many variables here. So you just want to think profit is not the same as revenue. Profit does include cost, revenue does not. You can think of it as income minus your outgo, or income minus what you have to spend. So let's look at this example here. We have our price demand. You might have seen this from some homework you have done already. So they give you the equation, and they want you to plot the price demand on the same axis. So we don't have any axis here. So what I would suggest is, let's just look at Desmos here. We're going to get used to Desmos. So we have P of X is 94.8 minus 5X. Okay. So tiny p of X equals 94.8 minus 5X. So you minus, see, where's my thing? So it's down here. So I'm going to hit the home icon here. And it might be hard to look at your graph, but if we zoom out a bit, we can already see, okay, that it's here. Okay. And you remember, you can hold your mouse over it to get any points if you need it. It goes through 0, 100, and the point there, 18.960, and it has this downward slope. So I would say use Desmos for the graph part. For the next part, what is the company's revenue function for this camera and what's its domain? So the domain will be the exact same as your price demand. So your revenue function, remember, it's just x times p of x, which in this problem is x times 94.8 minus 5x, which is 94.8x minus 5x squared. And the domain is the same. So it would be 1 to 15. So it wants you to use the revenue function to complete table 5, right? So here's table 5. So you could do that, but I would use Desmos. So let's figure out what the revenue is, and we need all these values. So revenue, remember we said it's R of X so we multiplied it out. So you could write certain things, but you want to practice. So we said it's this minus 5x squared. So, and then we need to complete it for certain things. So you could say R of, first one was 3. And you get it here. Then you could just erase the 3. And you could put the next one. But I'll just do all 3. So you could do R of 6. And then we needed R of 9. And then R of 12. And then R of 15. So we get these values here. So we see that revenue is going up as you produce the quantity. But what happens? It starts to go down after a certain point. Okay. So it looks like it's highest around 9. You could also look at the graph to do that as well. But we just needed to complete the table. So for the table here, we just use Desmos. Okay. And it wants you to sketch a graph using these points, so you could do that. So Desmos as well. So please get used to using Desmos for a lot of these things. And it says that's the last part here. So you have match problem 7, so you could go through that. And that concludes the video. So if you have any questions, let me know. Thanks again for your time.